Today we are going to discuss the second type of teaching method, that is programming methods. We already discussed teaching and teach through teaching method in previous class, and today we are going to discuss programming method. Actually, programming method in this case, that robot does not move point to point in the learning stage. In teaching method, we have to move the robot down through a series of points in order to learn or to teach that particular task. But in this case, we physically do not move the robot, but only identify the coordinates of the workspace. Okay, I repeat, the path of the motion is defined for the controller without having to move the end effector. Right. We have four programming methods, that is definition of coordinates by the computer, shifting coordinate system, use of vision sensor, and the pointer. World modeling. So these are the four types of program methods. I repeat, definition of coordinates by computer, shifting coordinate system, use of vision sensor and pointer, world modeling. Coming to the first one, this definition of coordinates by the computer. In this case, a controller can receive information about a series of points through which the end effector is to pass and can store them in a memory. So without actually having to move the end effector along the desired path, as we have done in teaching methods. Here we have to identify or to collect the information about the series of points of the workspace. For example, if a task is defined a series of numbers, that is for example 2, 3, 4 and 5, 6, 7. So these are the 2 points that a robot have to move. Identify the first point as robot move to the first place with the x-axis with the 2 units, then y-axis with the 3 units and z-axis with the 4 units. So the robot will move to 2 units in x-axis direction, 3 units in y-axis direction and 4 units in z-axis direction. So that is the particular point of task. If we shift the task area, that is if we identify the next place is 5, 6, 7, then the coordinate assigned x equal to, it will move to the next point, that is x equal to 5, y coordinate equal to 6 and the z coordinate equal to 7. As we have we already discussed that in the introduction, that if a room have tiles with the equal intervals, we can divide it into different spaces. I can identify 1, 2, 3, etc. with the equal length of tiles. So thereby we can identify the position. If we move x-axis 2 tiles, then y-axis with the 1 tile, we can identify the position. Similarly, in this case, we can identify by knowing the or by numbering the workspace. Okay, so that's all with the definition of coordinates by computer. It's a simple thing. Then second case is shifting coordinate system. In this case, if a robot perform identical task, identical task, so we can apply this method. A robot is taught to perform task at one mark with some coordinate system that is shifted to the next task area, enabling the task to be copied from the first place to the next work cell. Let's see. Let's take an example of shifting coordinate system by you can see a diagram here. That is 2 plates. That is one in station A and the other in station B. We have to make drill points in that place at equal points. So first we identify station A with the x-axis equal to some value and the y-axis equal to some value. So then we identify that point. The robot will move to that particular area area, drill that point, and the next step is shifting the coordinate system. So we can place that station B plate in the same work cell, and we can apply a shifting system that is identify XB. If a point is x-axis direction with the B plate, XB is equal to XA plus 11. That means 11 coordinate points can be shifted to do the task. And second case, that is YB, YA plus 6. So 6 units in the Y direction not to get the new task point to drill that particular point in station B plate. What is the advantage is that if we drill, if we finish the drilling of plate A, then we can go for drilling plate B, and that particular time is utilized to unload the first plate and reload a unfinished plate. So you can come back to the first position to drill that particular area, and while that time period we can replace plate B. So that's all with the shifting coordinate system. Okay, now the third one, that is the use of vision sensor and a pointer. By defining coordinates, we must know the numerical coordinates values of each and every point on the path before we start in defining coordinates. Okay, sometimes these values are unknown to the user. So what happens in this section, we can use a vision sensor that help us to overcome this difficulty. A narrow beam of light is used to indicate the point along the paths. As we have, the aeroplane finds or the pilot finds the path of runway during landing, right? We give a light path. So similarly, we can identify the workspace by putting a light beam there. Also, we can identify the movement of a mouse. We just move that mouse on tabletop, we get the cursor movement on the screen. Okay. Here the vision sensor, like camera, finds the location of the light spot and input them to the controller memory, and the light pen can be used as a pointer. Here. So that's the method we used in use of vision and vision sensor and camera. Okay, and the last one, that is the world modeling. That is the advanced method in programming method. The shape of all objects located within the robot work envelope are stored in the memory. So the controller must know everything about the items present in the work area. Robot has to identify the shape, diameter, weight, of mass, etc. of the particular item in the workspace. Also, it has to know the orientation of the item. Then only we know how to handle the object in the workspace. However, in this type of program method, we should require a large number of memory with a rapid computer, and also an advanced software. That is the disadvantage here in world modeling. So these are the 4 types of programming methods we used for teaching a robot. Okay, thank you.